Well, hello and welcome everyone to Module 2. Now, I know most of you are interested in seeing the final project for this section, as well as how to navigate the starter project for this as well. So that being the case, what I'm going to do is just speed run through these first few sections, and then we'll spend the rest of the time just pouring over the starter project, how to get it going, some of the common errors that people are encountering when using the starter project. And then finally, just what's expected of you on the final project, what the requirements are, and what you can do to be successful. So getting into it with lesson 1, what we're looking at here are the different types of memory that are associated with Solidity and the EVM. So when you're creating a variable that stores state, something that is going to be persistent, that is something that would be stored in storage. Now, storage is a type of memory that is on the blockchain itself. That said, it is the most expensive to use as it requires more gas. We also have temporary storage in the form of memory and stack. Now, in the stack, you can find different things such as function arguments. The compiler and the EVM will also use this for intermediate data, basically like a scratch pad for its operations. And memory will hold your local variables from your functions. So if we take a look at an example here, we can see in this contract we have variables of num, sender, and value. Now these are what you would call state variables. So these are things that would be in storage memory, because these are the variables that would be stored on the blockchain. These are the ones that we're saving to, these are the ones that we're getting information from constantly. But then these variables here, well actually that's not a good example. So what we'll do is just very quickly create one. So we'll just call this some num, and we'll set that equal to the argument that's being passed in. So if you had something like this, this would be stored in memory because this is temporary. Once this function completes, none of these values will exist anymore. And as such, they're kept in temporary memory, as it's a lot cheaper to keep them there as opposed to keeping everything in storage on the blockchain. So that's a quick example of that. Which brings us to the end of lesson 1 already. And of course there's a challenge for that here. If you're interested in kind of experimenting with this, creating a contract of your own with these different types of variables, you are free to do that and then share your challenge with the rest of us in Discord. Now moving into lesson 2. Lesson 2 is all about creating upgradable smart contracts. Now this is actually pretty cool because typically when you deploy a contract to the blockchain, it's permanent, it's forever, there's no changing it, right? So what happens when, say, your business logic changes, or you deploy your contract and then all of a sudden you realize there's a vulnerability? That's a really big problem. So how do we handle this? So we handle this using something called a proxy contract. And how this works is the functionality that needs to change, that would be contained in the proxy contract. But the rest of the functionality that is fine from the old contract, we just keep it there and then we call that from the proxy contract. So as an example of that, we'll come back to this code that you saw not too long ago. So here we have a contract called original contract. Here we have a contract called proxy contract. And what I've done is I've deployed both of them here. So for our original contract, we see the value is currently 0. We'll go ahead and set that to 5. Now our proxy contract, what this is going to do is, so you can see both of these have a function called setVars. All these do is it just sets the value of this number here. So what proxy contract is going to do is it's going to call the setVars in this original contract. And how it's going to do that is going to use something called a delegate call. Now, a delegate call requires a couple different things, which you can see here. It requires the contract address of the contract that you want to call. And then it requires any input that's required for the function that you're calling. Now, as far as telling it what function you want to call, you'd use this abi.encode with signature. Now, a signature is basically this beginning part of a function. It consists of the name as well as any arguments that it has, and then it's encoding that with whatever arguments are provided. And when we say encode, what this is doing is it's taking all this data and it's transforming it into a hex value. So if you want to see an example of what that looks like, here we have a function very similar to what we're working with, right? A set value function that takes in an integer. So when we encode this along with an input of 7, we get an output that looks like this. So this very first part of this hex value, this is actually the signature of the function in hex. And then the rest of this is going to be the input. And we can see that 7 at the very end here. And then this is just another example of that with a different function signature. As you can see, the value here at the front is different, as it's different from the first one. And then since we have two values here, we can see that this is a little longer. So the first value of 7 we can find here. And then since the value of 12 in hex is represented as the letter C, we have that letter C at the very end here. So that is how encoding works. And essentially when you do this delegate call, it passes that hex value to the Ethereum virtual machine. And that tells it the function to call, the values to pass into it. And then it returns with success or failure, possibly. And then if it's returning any data, that would go into this data value here. And so that's essentially how that works. And if we copy this contract address here and say we want to set this value to be 42, if we execute this, something interesting happens. If we look at our original contract, we can see nothing has changed. This is still the value of 5. But if we look at our proxy contract, we can see that even though it called the function in the original contract, that value was still stored in our proxy contract. So pretty cool. So one way you can think about this is that when you do a delegate call like this, it basically takes the logic of that function and replaces this with it, and then stores it into whatever value that you want it to store it into. Okay, so that is the quick and dirty of upgradable contracts. And again, we have a challenge here if you want to experiment with this and share your brilliance with the rest of us on Discord. On page 5, you can see some sample code. This is actually what I used in Remix. I just changed the function names to make it a little easier to differentiate between the two. So feel free to play with this and experiment with it. Going into lesson 3, what we're going to be talking about here is the different elements that make up a decentralized application. So in Web 2, when you're signing into a website, you typically use either your username and a password, or maybe you're using a single sign-in, like maybe you're using your Facebook to sign in or your Google account. In Web3, we don't have that, at least not yet. It's being worked on, but it's not there yet. So what we have are Web3 wallets. And now your Web3 wallet is your identity, it's your money, and it also contains your private keys and your public keys so that you're able to accept currency as well as to interact with applications and use your private key to verify that you're you and conduct those transactions that you want to transact on the application. So you have your wallet, right? You have your wallet as one very big part of a DApp. And the next part is you need some kind of library typically to be the go-between for your smart contract in the back end, your front end, and your wallet, right? And one example of this is web3.js. This is a JavaScript library that allows you to do just that. It has some predefined functionality that you can call to accomplish some basic tasks like connecting to wallets, getting accounts, getting balances. And then lastly is the actual front end of your application. Now you can use whatever you want for this. One popular framework to use is React. In that same light, there's also Next.js, which is what I prefer. But you can use whatever you want for this. And these three things combined essentially makes up your decentralized application. And here, if you're using web3.js, you can see some examples of the functionality that it provides for you out of the box. So here you can see there's a function called connect wallet handler that handles wallet connections for you. There's account changed handler, so if someone changes the account in their wallet, it'll detect that and automatically put that in for the default account as well as get the balance of that account. Using this get account balance function, right? This is going to get those balances. And then if someone changes the chain of their wallet, say you're in your Metamask and you're on Ethereum and you switch it to Polygon, this function will detect that, and then whatever functionality or logic that you want to happen when that change occurs will then execute once this handler detects that. And here's a sample project that looks like, we'll scroll to the bottom, it looks like this, where you can kind of play around with some of this functionality, and this is the code that you can find in that GitHub. So if you want to experiment with this, as far as connecting to MetaMask wallets and manipulating data and so on and so forth, you can use that GitPod for that. But now here we are. This is what everyone wants to know, what everyone is interested in. That is looking at a real decentralized application, all of its workings, and how to run it, how to use it. But before we get into that, this starter contract is actually going to be using ethers.js instead of the web3.js library that we were talking about previously. The reason for that is I find it a little easier to work with personally, and it's also the default library for Hardhat. And since we're going to be using Hardhat, it kind of just makes sense to use ethers.js. Now, if you're unfamiliar with React, this link will take you to a YouTube playlist of different lessons in how to program with React and create different things in React. So if that's something that you're interested in or you just kind of need a refresher, you can click into that. Obviously, if these videos aren't for you, YouTube is vast and React is super popular. So if you do any kind of search in YouTube for React lessons, you're bound to find something that you like. Now, in talking about this starter project, it has a pretty basic flow. So when you first load up this project, you're going to be connecting a wallet, and then once you connect your wallet, it's going to be displaying a balance for your account. And then you'll be able to see two different buttons. One that will allow you to deposit funds into your account, and then a withdrawal function that does, you guessed it, takes funds out. So with that said, this GitPod here will take you to the starter project in GitPod if you prefer to work in the cloud. Alternatively, if you want to run this locally on your machine, say using VS Code, you can click on this link here, which will take you to the GitHub repository. And then from here, you can see all the different instructions that will tell you how to load the project, get the dependencies going, spin up your hard hat, so on and so forth. So now with that said, let's just dig into it, right? So here is the project in VS Code. Now I've already cloned this to my VS Code. If you don't know how to do that, all you have to do is click this green code button, press this to copy this link, and then in the directory of your choice, you just type git clone and then paste that in, hit enter, and then that'll pull in all of these files into that directory for you. So let's get this going and see what this project looks like. So following the instructions here, it says to create 2 additional terminals, which you can do by clicking this plus button here. And then once you do that, in the first terminal, you can go ahead and type in npm I. What this is going to do is install all of the project dependencies for you. That is, all the files that make this work. Then once that is done, in your second terminal, you'll go ahead and type in npx hardhat node. What this is going to do is spin up a local development node or network for you. This is what you're going to be deploying your smart contract on. And when you're doing those interactions on your website, this is the network where all those interactions are going to be taking place. Now, when this spins up, you can see it provides you with a number of different accounts that you can use. And it also shows you the RPC URL for your hardhat node. If you're unfamiliar with what all of this is for, I'll show you that in just a moment. And then lastly, what we want to do here is deploy our smart contract to this network. Again, following these instructions here. So we'll go ahead and paste that in. What this is saying here is we're telling hardhat to run our deployment script, which is in our scripts folder called deploy.js. And one important thing you want to do is make sure that you have this network localhost here. If you don't do this and you try to run this contract, one common error that people come across is this error saying that there's been an exception because getBalance is not working properly. And if you encounter that error, that typically means that you did not deploy this contract to your local host. What you did is you deployed it to hardhat. So when you're calling those functions, it's trying to communicate with your smart contract through hardhat, but your contract is in your local node. So that's why your contract is breaking. So if you see that, that's why. So now that we have our smart contract deployed, which you can also see in your node too, So if you want to make sure that it's deployed, you'll be able to see that contract deployment here. Once it's deployed, you can go ahead and type in npm run dev. What that's going to do now is compile your front end and then create a kind of like a local server for your front end to exist on. So if you go to this URL, this is how you'll be able to actually see your front end. So here we can see it's at localhost port 3000. So if we go into our browser and we type that in, we can see our beautiful front end here. So fantastic. It looks like everything's working very well so far. So now that we have our front end, there's a few things that we have to make sure are set up correctly before we can really interact with this, right? So one thing that you need to do is make sure that your MetaMask is set up to actually interact with that local hard hat node that you spun up. So if you don't have that set up already, what you would want to do is go into your MetaMask, click on these three dots here, go to Settings, and then in Settings you can click Networks, and then you would click Add Network. Now once you click Add Network, you'll find a screen like this. If you're not seeing this series of inputs and whatnot on your screen, then maybe you still have to click Add a Network here. But once you're at this point, what you're going to want to do is put in the information for that local hard hat node that you just spun up. So for the network name, you can call it anything that you like. I'm just calling it localhost 8545. For the RPC URL, if you look at this terminal when we first spun this up, you can see this URL that it provided. This is the URL that you need to provide to your MetaMask. So you can see this URL is that same exact URL. The chain ID is going to be 31337. That's the ID number for the Ethereum blockchain. And then the currency symbol is just the symbol of the primary currency of that chain, which in this case, of course, is Ethereum, so it's ETH. And then once you have that set up, you just click Save. And from there, you would go into your MetaMask again, click on this box here to go through your networks, and then you would just go to whatever you called your network. In this case, again, I called mine local. Let's temporarily just go into Arbitrum. And then we go to localhost here. And there you are. So now we are connected. Now, one final thing that you have to do is, again, you can see that it provides these accounts for us to use. Now, these accounts only exist on the Hard Hat network, and these are also the only ones that you can use to interact with contracts on the Hard Hat network as well. The most important of which is this very first one. So now, when we deployed that contract, it has a field for an owner, right? And whoever deploys that contract becomes the owner. Now, since this account is the very first one here, when we deployed that contract, this account became the owner. So say instead of using this account, maybe you decided to randomly just pick this third one, right? So you pick this third one and then you go into your website, wherever that is at this point here, and you're trying to do a withdrawal or a deposit, and you're getting this console error message saying you are not the owner. If you are getting that error, this is why. Because you are not using this very first account here. So it's very important that you use this. Now, to set that up with your MetaMask, all you got to do is copy this private key. And then once you have that copied, you would go into, you would just click into this account tab here, click import account, and then you would paste that private key here, click import, and then once you do that, you can see I'm already on this account. You can see that the last numbers are the same, right? 2266, 2266. It says it has a starting balance of 10,000 ETH. It'd be great if that was real, but it's not. And you can see in the MetaMask wallet, that's what we have, right? We got like 10,000 ETH. It's a little less because I've already used this account. So with that, you have your MetaMask now set up to interact with your hard hat node. You have your account that you're going to be using to interact with this. So it looks like we're all good to go, right? So let's go ahead and connect to our contract. We'll use MetaMask. And that's actually not the account we want to use. So let's go ahead and make sure we're on the right account. So we'll go ahead and change to that 2266 account. And we'll go ahead and refresh. And we're still using MetaMask, of course. Now it's still showing that old account. So how do we handle this? Now ideally you would think it would handle that kind of on its own, but sometimes if you have multiple accounts all connected, it gets a little confused. So I think one way that we can handle this very easily is to disconnect those accounts that we don't want to use. So if you click this globe, it shows all the accounts that you have connected to the website. So here we can see that AD account that's causing us trouble. We'll go ahead and click these three dots and then click disconnect this account. And then while we're here, we'll go ahead and disconnect this one as well. For good measure, we'll just completely close that tab too. So we'll bring it back up, click connect, use MetaMask, and now we have the correct account showing. So if this is a problem that you are experiencing yourself, now you know how to fix that as well. So we're in our account, we have a balance of 1 ETH. Let's go ahead and try to deposit another ETH. So let's click there. We see our MetaMask pop up asking us to confirm that we actually want to send that 1 ETH. We do, so we'll click confirm. So now, one thing that can happen is you'll get an error saying that your nonce is too, it's kind of cut off here, but it says it's too high, I believe. So this is another common error that people come across. How you get this error is when you've already interacted with the application and you've left it and you've reopened your VS Code, basically spun everything up again, redeployed everything. Your MetaMask wallet will say that perhaps you've already done 3 transactions, which is your nonce, right? 3 is for your nonce, right? But your application believes it's your very first time, so it thinks your nonce should be 0. So now you have this conflict which is generating this error. So all you got to do if you encounter this is click into your MetaMask, click the 3 dots, go into settings, click into advanced, and then right here there's a big red button that says clear activity tab data. Go ahead and push that. And then what that is going to do is just reset everything to 0. So now as far as your MetaMask is concerned, this is your first time interacting with this as well. And so now that these two things are in agreement, if we click deposit now and click confirm, we can see everything worked as it should. We now have a balance of 2. And if we try to withdraw that, we can see that is working correctly now. So everything is a success. So at this point, you're set, right? Your hard hat is set up, your wallet is set up. I think we've now covered all the errors you can possibly encounter at this point. So from here, you should be pretty good. If you're already familiar with the code of this project, at this point, if you want, you could basically tune out and proceed to the project if you like. From here, what we're going to do is a deeper dive into this project code. So here we can see our Index.js. Seems like a good enough place to start as any. Here you can see a few different values, right? So here we have some imports. We're importing React, which is the framework that we're using for our front end. We're importing ethers, which is that JavaScript library, which is facilitating all the communication between the moving parts of our application. And then we have something called an ABI here. Now, this is a file that's generated when you compile your smart contract. We can see that exists in artifacts, contracts, and then assessment.json, because that's what we called our smart contract. It's called assessment. And an ABI is basically just a file that describes all the different inputs and functions that exist in your smart contract, the different data types that are involved. And it's something that's just necessary for a lot of function calls. So you need it, okay? And this is where you can find it, and this is where it's being stored. But as you saw, there's a lot of JSON in that file, and what we actually want is just the ABI. So if you look down here, you can see that we're doing a dot operator here for ABI. When we do that, we're just getting the ABI portion of that JSON, and we're storing it into this variable here. For the contract address, if you're wondering where this is coming from, way back at the beginning, when we deployed our smart contract, you can see it told us that we deployed to this contract address, and that's the exact same address that we're storing here, okay? Now, if you decided to deploy this onto Goerli or Polygon, then obviously whatever that deployed contract address is, you would have to replace that here. Now, these variables above here, these are state variables. These are something that's part of React. So ETH wallet, or I should say useState, is part of React. It's just a way to define persistent variables and get them and set them relatively easy. So here we have ETH wallet. What this is going to store is the Metamask object in our browser's window. Our account variable is going to hold the user account that's being used in that MetaMask wallet. ATM is going to store our smart contract, or basically what we use to access the functionality of the smart contract. And then balance is going to hold the balance that we saw in that front end, this right here, okay? And then how this is set is with these functions that are defined next to it. So set ETH wallet, if you call that, whatever you pass into that will go into this. If you call set account, whatever you pass into this will go into account, so on and so forth. Now when you're initially defining these, you set them equal to useState, and then whatever's in between these parentheses is going to be the default value that goes into these variables. Here we're passing undefined. This way, if we want to check to see if something is undefined, it'll be very easy since it has that initial value. If it comes up as something other than undefined, then we know it's been set and it's ready to go. So from here, I believe the next logical place to go would be our HTML code here. So here we have our main component, which is essentially a container. And we have this container here just so we can style it, right? So we have this CSS here just to make it a little prettier. What this is doing is just taking all of that text and then just aligning it into the center of the page. Here we have the header, which is that welcome to Metacrafters ATM. And then here is where the real magic happens, right? This is where all the functionality comes in. So this function is responsible for creating all the on-demand dynamic HTML of our page. So if we go up, we can see that function right here. Now the first thing that this is going to do is check to see if we have set the wallet. Now if the wallet has not been set, if it doesn't exist, then what we're going to do is have a message on here saying to please install Metamask. If the wallet exists, then we're going to go and see if we have set the account. So if the account exists, then what we're going to do is ask them to connect with that account. So that is, if we refresh the page, since it detects that we have the wallet, we are now in that phase here, this one here. And that's why it's showing the please connect wallet. And then when you click that button, it's going to call this function, which is connect account. So now we'll just trace our way to the connect account. So connect account is going to check to make sure that the ETH wallet is still there. If not, there's going to be a little alert window that opens up saying to get MetaMask because it's required. Otherwise, we're going to go in here and we're going to use ethwallet.request to get those accounts associated with the wallet. And then once we have those accounts, we're going to pass that into our handle account function. So now we'll go to our handle account function. Here we're making sure that the account that has been passed to it is valid, or at least that it's defined. If it is, then we're going to say that in our console that the account has been connected, and then we're setting account with that account value. So this is that set account that we saw just up here. Okay, so that's going to set that account information into this variable. Now once we have the account, the next thing that we're going to want to do is to get access to our smart contract, which is what this function here does. So let's go ahead and find our get ATM contract, which is right below. So once we get into this, the first thing that we're going to need is the provider. This is our connection with the wallet, right? So we're going to pass in our wallet object to this Web3 provider function, which is going to provide us with that provider. From there, we need the signer from the provider. The signer is essentially the thing that approves or rejects transactions. And then once we have both the provider and the signer, we can go ahead and get that link to our smart contract. So with that, we just use ethers.contract. And then what it's going to want is the address of the contract that we want to connect to, the ABI of that contract, which you remember we saved above in that variable, and then lastly the signer. And then once we have that, we're going to store that into this ATM contract variable, and then set ATM to that value, which again is this function here. We're just putting it into that ATM variable there. So now that we have our ATM object, we go ahead and return to our init user. So at this point, we have our MetaMask, we're connected, we have our ATM object. So the next thing we're going to do is check to see if our balance is undefined. If it is, we'll go ahead and get that balance of this account. So we'll go to the getBalance function, which is going to be up here. Here we're checking to make sure that that ATM object still exists. If it does, then what we're going to do is call the setter for that balance variable above. And inside of it, we're going to call atm.getBalance. And then once we get that balance, we're going to use this toNumber here. That just converts it into a number that's a little more friendly for use with React. And if you're wondering what this async await thing is all about, when you call this function, since it's interacting with the blockchain and that takes time, it's something that sometimes could be almost instant or it could be 5 minutes from now. What you're saying here is that we're going to wait for this to finish, and then once it's finished, we'll go ahead and place that value into this function. Now, if something is marked async, that means if there's any other logic that we need to run while this is waiting on this, it'll go to that. So it'll continue to call other functions or do other rendering. And then once this signals that it's ready, that it has the value, it'll return here and then set that balance. Okay, so that's kind of just a little crash course into what async await is. To make it a little more clear, if you're talking about synchronous code is the code that just goes from top to bottom, right? So here's a synchronous function. So when you call this function, you know it's going to do this, and then it's going to do that, and then it's going to do this, and then this, right? That's synchronous. But if you have something that's asynchronous, like say for instance, this was asynchronous, while this is running, it would not go to these, right? Say it still needed to run these functions, so it would leave here, run this, and then when this says it's ready, it would go ahead and set this, and then resume this execution. So, kind of cool. So anyways, a little crash course in that. So we have our balance. So once that is set, now we can see that final UI for the user. So when we click here, we connect, we got the balance, and now we're displaying the buttons, the account information, all of these things that are defined here, this HTML. So we have this div, and we've got this paragraph element with our account variable, and we have our balance variable here. We have our two buttons. So if you click this button, you can see it calls the deposit. If you click withdraw, it calls the withdrawal function. And then this is the text for the buttons. Now if you wanted to trace the logic for this, so if we click that button and we go to deposit, this is another asynchronous function because again we are going to be interacting with the blockchain. In this case we're going to be writing to it. So again here we're just doing another check to make sure that we still have that connection to the smart contract. If we do, we're going to go ahead and call the deposit function of our smart contract, passing in the value of 1. And then once that has finished, we're storing that into our transaction. And here we're doing a transaction.wait. So while this is running, while we're waiting for the final confirmation from our MetaMask, this is just going to pause, right? And then once this finishes, it will call getBalance. Now the reason why you want to have this wait here is because if you don't wait for this transaction to finish, what's going to happen is it'll just go right through here, call getBalance, and most likely it'll still show that 1, right? Because the transaction hasn't finished. And so you lose your balance, right? It's no longer in sync with your back end. So that's why you want to wait for that transaction to finish, or else things are going to get a little wonky. And then withdrawal works the same way, except we call the withdrawal function instead of deposit. And with that, that is all the code for our front end. Now there's only one thing that we didn't cover here, which is this use effect. Now a use effect is something that will just automatically run when you load the page. So when we first load this page, we immediately call this function called getWallet. So if you were kind of confused about how this was set without calling anything, this is how it was set. So when we call getWallet, it checks to see if that Ethereum object is in our window, in our browser. If it is, then all we're doing is setting that ETH wallet variable to that object. Okay, and that's how that is set. So that covers the front end. With that, I believe the next step would be to cover the actual smart contract, so you can actually see the things that are being called here. So for the smart contract, we have a couple different state variables. We have the owner, which is being set when you deploy the contract. We have that balance variable, which is the one that you see from the front end. So when you call getBalance, this is that variable that we're getting that information from. We have a couple different events here, so every time we do a deposit or a withdrawal, we're firing those events for our log. We have a basic constructor here, which takes in an initial balance value, which is set to our balance. And then this is also how the owner is set. So again, whatever account deploys this is just automatically going to be put into the owner by this constructor. And if you're wondering where this value comes from, if you go into scripts, deploy.js, you can see when we deploy, we have this init balance here of 1, and this is where that's coming from. I'll cover that deployment script in a moment, but just so you have an idea of where that's coming from. Here is the getBalance function, which just returns the balance. That's pretty straightforward. Our deposit function takes in a value, and then what we're doing is saving the previous value before we update it. This is so in the end we can do this assert to make sure that it changed the way it was supposed to. Here we're doing a check to make sure that it's the owner that's depositing into this account. Once we verify that, then we're updating the balance with that value that's being passed in. And then we're doing that assert using that previous balance, adding the passed in amount to it, and then making sure the balance is equal to that. If it is, then we know that this function completed successfully. At which point we'll go ahead and emit that deposit event, and then we're good. Same thing for withdraw. The logic is very similar, except we're going to be withdrawing funds instead of depositing funds. So again, we're checking to make sure that the owner is the owner. We're storing the previous balance, so we can do that assert check at the end. We have one additional thing here, which is making sure that the account that's doing the withdraw has the funds to actually pull out. So as long as their balance is greater than the withdrawal amount, then they'll be able to proceed. If it's not, if the balance is less than the withdrawal amount, then we're going to revert with this custom error that you can see right here. Otherwise, we'll do the withdraw and then the emit event. So that is our smart contract. And then going back to our deployment script. So again, this is what is run when we call this command here, this hard hat run. So here we're setting an initial balance that we want to put into our contract. This line is calling a method called getContractFactory. And here we're passing in the name of our smart contract, which is assessment. And then once we get that contract factory, we're telling it that we want to deploy that contract, and we want to deploy that contract with that initial balance. So you can think of anything you pass into this deploy function as the data that's being passed into that constructor, this constructor that we see right here. So that's going to be passing into that value there, okay? And then we're just waiting for that to be deployed. And then once we have that confirmation, we're just getting the address that it was deployed to, and then that initial balance that we set it to for outputting in the console, which you can see right here. And with that, that covers all of our code. So with this project, obviously we provide this to you as a template, okay? But we don't want you to just put this in your GitHub and send it back to us, okay? If you do that, we are going to reject your submission. What we want you to do with this is, for instance, to come into the smart contract and alter some of these functions. So change them to do something else, or if you want to keep these, maybe add some new functions here. And then go into your index and then just set up that functionality so you can call it from here, right? And you already kind of know how to do that because you have all these other example functions showing exactly how to call these functions. So using that as a template, you can set up buttons, right? You can add extra buttons here to call functions just like these, to call like the new functions that you've made. You can set up new values to display. And then of course, if you want to change up your front end, that's also really nice to do as well. So here you can add any additional CSS that you want. So if you want to put like a background image or change the color of the text background or the color of your text or the buttons, you can do that here. We just want to see some kind of effort, right? Now you don't have to completely rewrite it, okay? If you want to just add one or two functions to your smart contract, that's fine. And then, of course, update your front end to work with that. I think that's acceptable. We just want to see an effort, okay? So as long as we see that, then it will be approved, okay? So just make an effort. Don't submit this back to us because we get a lot of submissions that are pretty much copy and paste, or you just change this to, welcome to Bob's ATM. Boom, I'm done. Submit it. No, don't do that, okay? We need a little bit more than that. So with that warning, let's go ahead and talk about how to get this working with GitPod. Now the process is pretty much the same. So we'll go ahead and spin up this GitPod, which should just take a moment to get going. So now we have our GitPod running. We can see that it's automatically calling npm install for us, which is nice. Once that finishes, we'll go ahead and create the other two terminals that by now we know that we need to make. So we'll go ahead and do that. We'll call our node. So here you can see it's available on port 8545. We'll go ahead and make that public. And here we'll deploy our contract just like we did before. And we'll just copy that in here. Again, still running that network localhost part, very important. Okay, so we can see it's deployed and to that same contract address. That will never change, okay? Just as an FYI. We can see here in our node that it did deploy successfully. So now what we'll do is go ahead and spin up our front end with npm run dev. And we will open that in our browser. So here you can see that our front end is loading, but there is one problem. So even though we have a hard hat node running and we still have our hard hat network selected here, you can see that it can't connect, right? And the reason is that because this is running on a virtual machine, this RPC is actually not correct. That's correct for that virtual machine, but it's not correct for us, right? So what we actually need is if we go to ports, this is going to show the address for all of the ports. So this here is going to be the actual RPC URL for this GitPod instance. We can see here that it's public. If this lock is locked, click it to make it public. What you'll want to do now is copy. You can either highlight it and copy it, or you can click this copy icon here. And from here, what we want to do is add a network again, but this time you're going to be setting up a network for GitPod. So here is one that I set up previously. Now this one doesn't work because this was a different virtual machine. Every time you run GitPod, it's going to be a different URL. So that URL that we got from here, we're going to paste here for our RPC. And the chain ID is going to be the same, 31337. The symbol is also going to be the same. We'll go ahead and click Save. And we can see that it connected successfully. Now the nice thing is that all the accounts still work. So the only extra step that you have to do with GitPod is to just set up that GitPod RPC URL. Once you do, and you are connected to that network like I am, I called mine GitPod, then you can go ahead and interact with this like normal. You can go ahead and click the button. We'll use Metamask. We're going to be using that 2266 account because again, that is the owner account. We'll connect. We see that initial balance of 1. We'll go ahead and deposit. confirm, and we're getting that nonce error because we've already used this before, right? So let's go ahead and clear that one last time. Going to Settings, Advanced, clear Activity tab Data, clear. And now that we've done that, if we click this, click Confirm, it works successfully. So that is how to get MetaMask working with a GitPod instance. So with that, we are done. Now I know that was a ton of information, but I hope it was very informative. I hope that answers all your questions as far as errors, what the code does. Of course, if you have any questions that I didn't cover in this, you can reach out to us on Discord. We're more than happy to help you. Good luck again with your project. I know you're going to kill it, and I will see you in the next module.